In part 2 of the homework, we're going to graph some equations. Now, the homework's going to ask about graphing equations in xy intercept form. I also have a word problem down here where we're going to write an equation, and then we're going to graph using the slope-intercept form. So let's take a look at this xy intercept form first. Well, the first problem, when we want to find out what the x-intercept is, remember you're going to end up setting y equal to 0. And so when we do that, it cancels out this y term. So remember, we're left with this 1/2 x equals 2. So in order to get rid of a fraction as a coefficient, you want to multiply by the reciprocal. So we're going to multiply by 2 on both sides. And you see that's 2 over 1. Those 2's will cross cancel. Now once we do that, we're left with an x equals 4. So what we can do there is go over 4 spaces on the x-axis and put a dot. Then we can find the y-intercept. Now remember, the y-intercept is when we set x equal to 0. So if I set x equal to 0, it cancels out that x term, so all I'm left with is the y term. And so all I have is a negative 2y equals 2. So from that point, all we need to do is divide by that negative 2. Always be really careful on the signs. Make sure you bring those down, especially in the division here. Sometimes people leave those signs off and get the wrong number. In this case, we get negative 1, and we plot that as the y-intercept, just 1 down on the y-axis. There we've got 2 points. We can draw the line between them. Well, here's another example. Again, when we're trying to find that x-intercept, all we're going to do is cancel out the y term. So we're going to, for the x-intercept, we're going to set y equal to 0. So it cancels out that y term, so all we're left with is 3x equals 15. So you just have one step there of dividing by 3, and you've got your x value all by itself. So this method works really well when x and y are on the same side, when you don't have to do a lot of opposite operations to isolate the variable. So over 5 spaces on the x-axis, we put a dot, and we move on to the next intercept, which is the y-intercept. So for the y-intercept, we're going to go ahead and set x equal to 0. And that will cancel out the x term, leaving us just with y. So now I've got 5y equals 15. So I can go ahead and do some division there and see what's left over. Divide by 5 on both sides. Y is 3. So up 3 spaces from the origin, and then we put a dot. And now we've got 2 points where we can draw a line through. So again, it works real well as long as x and y are on the same side, like they are here. And so we'll go ahead and find out what that y or x-intercept, I guess that's what we've been finding first the last few times. So for the x-intercept, remember you're just going to set y equal to 0. That cancels out the y term, leaving us with a negative 2x equals 12. Well, you can get the answer by just doing a one-step operation there. Divide by negative 2. And negative 2, well, goes into 12 6 times. So x equals 6. So over on the x-axis, actually it makes a negative 6 because we have a positive over a negative there. So you've got to be real careful with your signs. Hopefully you're a little more careful than I am there. So we go over on the left-hand side of the x-axis 6 spaces. So that's 1, 2, 3, 4, 5, 6. And we put a dot. Then we can do the same thing, find out what that y-intercept is though. So remember, for the y-intercept, you're just going to set x equal to 0. And so when we do that, this term cancels out, leaving us only with 3y equals 12. So you just have one step in this case. We're going to get rid of that 3 by dividing by 3 on both sides, leaving us with y equals 4. So we just go 4 spaces up. 1, 2, 3, 4. And we put a dot. Now we've got the 2 points. We can draw a line between. Well, that's using XY intercepts. It's mainly what you'll be doing on that section, but let's take a look at a couple other types of problems. Here's a pond is stocked with 300 fish. Each year the population decreases by 25 fish. All right, right here. The population decreases by 25 fish each year. Well, that tells us something about the years. The number of fish depend on how many years they're in there for. And so that tells us that the number of fish is our dependent variable. Years is our independent variable. So let's write that down. Independent means we can pick anything for that. The independent variable is the number of years. And so that's going to end up being our x value. So we're going to use years for x. Our dependent, now dependent means that it depends on something. So, for instance, the number of fish in the pond depend on how long they're in there for. So dependent is equal to the number of fish, which we will call our y value. So years is x, number of fish is y. So we could write this way. We could say the number of fish equals, well, it started at 300. So I'm going to put 300 here. That's what we started with. So it's a positive 300. Don't have negative fish. But it's decreasing by 25 fish a year. Well, if we multiply 25 times the number of years that we're going to end up having these fish in this pond, that'll tell us when they'll end up running out. So there's our equation. We wrote our equation. So y is our independent, y is actually our dependent variable. It depends on the number of years being multiplied by 25 and then adding 300. So let's take a look at our axes here. Came up with just a quarter of a coordinate plane. The y-axis is here, and this is our number of fish. And the x-axis represents years. So let's say this is going up by hundreds here. So our y-axis is hundreds, and our x-axis is just going by ones. So ones here. So we're going to start at 300. That's where we're starting at. And then each year it decreases by 25. So that tells us that after 4 years, we're going to be down to 200. So 4 years later, we're at 200. So down 25, or down 100 fish, I guess, over 4. And then we can do that again, down 25, or down 100 fish. It brings us over another 4 years. And then we do that one more time, down, and then over. It would be right about that spot there. So that'd be 12 years down the road. We would have no fish in the pond. Well, there's an instance where we had to write an equation using two unknowns. We used the slope-intercept form to graph that, and we're going to do the same thing on these last few problems here. So if we're graphing using the slope-intercept form, remember, we want to start with that y-intercept right there, -3. So you go down 1, 2, 3 spaces, and you put a dot. And then we use the slope. Remember, the slope is a fraction. So this is our slope, where it tells us to do something. So m equals 2 over 1. What's that 2 tell us to do? Hopefully you said up. What's the 1 tell us to do? Right. So up 2, right 1. You can do that a few times. It gets you on that line. Well, we could also go the other way. We could end up going down 2, left 1. That'll get you on that same exact line. And you got plenty of points to be able to draw a nice line through. Well, one more problem to take a look at. This one we're going to use slope-intercept form, but x and y are on the same side, so you could end up using the xy-intercept method. But let's say we wanted to use slope-intercept form. If I want to do that, you have to get y by itself. So if we've got a half x next to it, I have to do the opposite. The opposite of plus, which is minus. So I have to have minus 1/2 x from both sides. And now I'll have it in the slope-intercept form. So a common mistake I see on tests is when you're trying to graph using this method, either you don't move the term over or you don't get rid of the coefficient in front of y. Well, we had no coefficient this time except for 1, so just need to move that 1/2 x over. Always have to have y by itself. So we're going to start with that y-intercept, +4, up 1, 2, 3, 4 spaces. And then we use the slope. This time the slope, though, is -1 to 2. So let's take a look at that. -1 to 2. The -1 tells us to go down. So down 1 space. And then the 2, positive, tells us to go right. And so we're going to end up going down 1 over 2 to the right. Do that a few times, got some points on the line. You could also go the other direction. Could be 1 over -2. That tells us to go up, but then to the left. And so up 1, left 2. Gets you on that same line. Once you got a few points, draw a line through those points, and you've got it made. Well, that's a little practice graphing, and that'll be the second part of the homework tonight.